Okay, I have created a pipeline which loads data from 3 weather stations. In this pipeline we have for each loop, and it iterates over these 3 stations. First, let's start from the root of the pipeline. Here we have parameter called channel list. These are the channels from where we are getting the data. And this channel list is an array of 3 elements. So for each weather station, for each loop, which goes through this channel list. So this is pipeline parameters channels list, and it takes parameter from the root of the pipeline. I'm clicking to the background. Inside this for each weather station, I have 2 blocks. I have a weather to notebook, and I have a wait parameter. Wait is done for 3+ minutes, and it is needed because I don't have enough capacity to run notebooks faster. One important thing is that for each loop has sequential parameter set. This means that the elements of the loop are not run in parallel, they are run sequentially. One is completed and then another starts back. So basically I am running notebook, waiting 3 minutes, then I am running another notebook. I can't run it faster because I don't have enough capacity. So let's have a look at the notebook itself. Notebook accepts parameter channel ID, which comes from for each loop container. Here in the settings of for each loop container, I have base parameters, and channel ID of type string is map to the value of item, the current item of for each. So here in the notebook I am using this channel ID. This is the amount of results I am getting. This is the URL of the service, and this is the parsing code. So it loads the data into the data frame, actually Spark data frame, and then it saves it into database. I have already covered in the previous exercise that I have partitions. Here in this exercise I have partitions by year, month, day. And we can see in a delta log that data was saved in this partition fashion. So we have year, month, and several days under month. Yeah, there are 7 days under 12 months. Inside the loop, after we have loaded the data for particular channel, we're making loop per partitions. So the data which comes can cover several days. So there is a loop for partitions, and partitions are a key consists of year, month, and day. These year, month, and day are coming from event time field of the data we've got from channel, and here we are using them for partitioning. There are 3 sections of the code. First section is table doesn't exist at all. This is delta table, which is placed at this path, which is a path at my lake house. We can see this path here. You can click on it and copy this ABFS path, and this path is in this variable. Here it is, and it points to the file section of the Delta Lake. Okay, let's come back to this partitioning loop. We have three situations. First, table doesn't exist at all. We do this preliminary query and check if any records for this partition exist. If such a record exists, we're merging partition, we're running merge, where target is a delta table and partition data frame is our current data frame for this year, month, day, and we merging them one on top of another. So merge consists of either inserting new data if they did come, or ignoring data if it already existed. Now, if partition doesn't exist, we are writing data in append fashion. So this means that table exists, but no data for current partition. So we are doing partition data frame, format delta, mod append. We are appending partition. And this is the code where we are creating the table from scratch. So if no table exists, we are simply creating it. And here is this type of code. Okay, so table exists true means that we should not attempt to create it again. So I'm paying attention that we can do more than one partition right. We have requested data. This is how the data actually looks like, original data, and it has created at timestamp, and it can belong to various dates. Thus, when we retrieve data, we can get data for number of partitions. Okay, this is the table which was created on top of this data lake file structure, this partition data lake structure, and this table is also partitioned. Okay, we can display sample data from it. Here we can see it, and it consists of channel IDs and the channel entry ID, specific entry for this channel, and various fields, event time, temperature, and so on. This is the history of commits that already happened on this table. As we can see, we have here merge and write commits, which either created partitions or appended them. Here, mod append partition and certain partition value. It was a write mod. And here was the merge operation, and it had this predicate where it compared channel, year, month, day, and entry ID, and based on that it appended or not the new data. So the table, the job has already run several times, so we have these merge and write operations for several channels. Here is the data which was obtained. This is channel ID. There are 3 days for this channel, and okay, I have mistakenly rerun the query. So again, this is these are 3 records for the channel, and they belong to 3 days. This is a count of records, and these are average values of 3 fields: temperature, wind speed, and humidity. So the first channel has some strange temperature, the second has sensible temperature, This is the temperature, average temperature during the day. This is wind speed. So wind speed looks logical, and humidity looks logical for first channel and the third channel, but doesn't look sensible for the second channel. Anyway, this is the amount of records per day, and the last two channels returned records for 7 or so days backward, so I was able to load them. And this was the run history for this pipeline. So weather block runs for 3 minutes and await runs for 3 minutes, and they download the data. Well, it might seem too long, but I actually have intentional delay here. So both in the notebook itself, it waits for 2 minutes, and for 3 minutes after. So the actual loading and saving of data is done for about 1 minute. And I make these waits so that resources can be freed, because on this trial capacity I can run only one notebook at a time, and I should wait until sometime 3-4 minutes for resources to be available. Okay, that was all for this exercise. This is a complex pipeline, somewhat reminds Microsoft integrations services of old times, but this is under Azure, specifically under Microsoft Fabric.